Hi again, guys. This is Mrs. Lindsay back again for part 2 of converting your standard quadratic equation to vertex form. What happens if my lead coefficient is not 1? How can I remove that lead coefficient? Mr. Falco, Ms. Persico, say hi. Hope you guys have been well. Hope yesterday's lesson went well. Let's get into it. Here I have a lead coefficient that is -1. We still need to do the first thing first and remove the constant. Always remove the constant first. It's a -16. Although 16 is a perfect square, it's certainly not the perfect square that we want, and anyway it's negative. It's not going to help us. So we're going to remove that perfect square, or that -16, by adding 16 to both sides of the equation, the addition property of equality. That'll give us p of x plus 16 equals -x squared minus 10x. Here's where you have to wait and look at what you have. Your equation is not in the correct form to complete the square. We need to not only remove the constant, but now we need to remove that lead coefficient. And we do that by factoring. So if I have a -x squared, I need to factor out a -1. So I'll leave this p of x plus 16 equals -1 times x squared. This time it's plus 10x. I have to change both signs. And now I'm going to add my blank within the parentheses, close the parentheses. So that coefficient of -1 is going to get multiplied by all three terms in the trinomial. I'll show you a neater version of that on the next slide. P of x plus 16 equals -1 times x squared plus 10x plus my blank. And remember how to get the blank. We take the middle term, which in this case is 10, divide by 2, half the middle, and square it. Half of 10 is 5, squared is 25. So we're going to add 25 to the blank within the parentheses. Again, wait. We can't add the 25 to the other side the way it is, because on the way out, it's within that parentheses, it's not really positive 25, it's multiplied to -1. So you need to multiply the 25 in order to take it out of the parentheses to the -1. So on the other side, you're really adding -25. All right? So two things to worry about. First of all, you can't add the blank right away without factoring out the lead coefficient, in this case -1. Secondly, you can't add your perfect square to the left side of the equation until you've multiplied it to the GCF, which is in front of the parentheses. Once we've done that, we can add p of x plus 16 minus 25, which gives us p of x minus 9, equals -1. Now we have a perfect square trinomial. X squared plus 10x plus 25. Okay, so a couple of the dangers. Before adding anything to either side, factor out the -1. Divide everything by -1. Okay, once you find your perfect square inside the parentheses, before adding it to the left side, you must multiply by the GCF. Once you do that, everything is very similar to what we did yesterday. When we add 16 and negative 25, we get negative 9. Negative 1 is your GCF. The trinomial is a perfect square. It's going to be crunched into this binomial. X squared becomes x, 25 becomes 5, and that 5 has to be half of the 10, so it's x plus 5 squared. It's all good. We have one more thing to do. Notice how the negative 1 is now still the lead coefficient. It's just in front of the parentheses. We have one more thing to do, and that is to add 9 to both sides to solve for p of x. Once you do that, I bet you can find the vertex. So you have p of x equals negative 1 times x plus 5 squared plus 9. What could our vertex be? Well, the inside is the opposite of the x-coordinate, so that's negative 5. The outside is the same sign as the y-coordinate, that's positive 9. We can check that on Desmos, but one more thing. Could this be concave up or concave down? Well, the lead coefficient is still negative 1, just like it was in the original standard form trinomial. So because it's a negative, it's going to be concave down. Just to be sure, we're going to check that with Desmos. And there's our original trinomial. And there's our concave down parabola with a vertex at negative 5, 9. Perfect. So remember, your lead coefficient never changed. It's still negative 1. Parabola is still concave down. The vertex, we could have gotten the vertex by finding the axis of symmetry and substituting. We could have tried to find it on the calculator, but this way is foolproof. We'll try one more just to make sure we've got it. Again, before you do anything, either way, before anything happens, you must remove the constant. The constant is 2. We're going to add negative 2 to both sides. That'll give us r of x minus 2 equals negative x squared plus 4x. Hold everything. Before you add a blank, you need to remove that lead coefficient by factoring out a negative 1. That's going to change all the signs. So you have r of x minus 2 equals negative 1 times x squared plus 4x. Now you can add the blank inside the parentheses. We're also going to add a blank, I'll put it in a different color, on the other side of the equal sign, but it will not be the same number. The number that we're going to add inside, make it green, inside the parentheses is half of 4 squared. Half of 4 is 2. 2 squared is 4. So coincidentally, we're going to add 4 inside the parentheses. But as it comes out of those parentheses, it gets multiplied by negative 1. You cannot release the 4 from the parentheses until you've multiplied it to the GCF. So it will look different on this side. On this side, it will look like a negative 4. Combining like terms, we have r of x minus 6 equals negative 1 perfect square binomial. X squared becomes x. 4 becomes 2. And that's half of the inside term. And now all we need to do is add 6 to both sides. And now I'm sure, getting it in vertex form, you can probably find the vertex. You can also tell me if it's concave up or down. So r of x equals -1 times x plus 2 squared plus 6. Vertex, inside is the opposite sign, -2, that's the x coordinate. Outside is the same sign, that's 6, that's the y coordinate. It's concave down because of the -1. And you're probably able to graph this. Let's check Desmos first. Parabola is concave down. The vertex is at +2, +6. We can graph this just by looking for the vertex and knowing that it's going to be concave down. If the vertex is at 2, 6, let's count 2, 1, 2, 3, 4, 5, 6. Once I found the vertex, oops. One, two, 1, 2, 3, 4, 5, 6. Once I found the vertex, I can use the pattern concave down. The coefficient is -1. And it looks something like, something like this, rough sketch, r of x, and there it is. Okay, it's now your turn. You have the slides to help you. You can play this YouTube video again if you'd like, and I'll see you tomorrow. Next video, we'll talk about coefficients other than 1 or -1. Be good, work hard, see you tomorrow. Bye.